And that's also another thing I paid for with my own money. That's so I can make the videos and try to help out as much as possible. So, like I said, just let me know if you need the recording. I'll hook you up. But that being said, we can continue on. So I need the wiring diagram. I need connector view. Also, I need a what? What do you think else I need? It's been too long, hasn't it? Say it again. Yeah, my man, working on it. God damn. Did you get that tattoo or what? So we need to know the component location. That's the third thing. So as far as tools, we're probably going to need a voltmeter and a scan tool, but we'll see. Obviously, we can get all the way radical and go to oscilloscope if, if we want to, but we're going to look at that wiring diagram and then assess what we're actually going to need. Okay, so where's the wiring diagram? Wiring diagram is right up here. And the good thing about this wiring diagram is it's expandable. So at this point, I have to be able to look at the diagram, and it's a little bit harder to read. This is not a compartmentalized wiring diagram. It's a combined wiring diagram. It is semi-interactive, but you can't highlight things on this diagram. So what number would you say is the fuel pump in this particular circuit? And the component number might be like F6 or 10, F5, 43. Which one of the component numbers is the fuel pump? And hopefully you notice what I did, because that should be the same way that you're approaching um, your diagnostic routines. I started with the question, which one is the fuel pump? Not which one is the fuel pump relay, right? Yes. 37 is the fuel pump uh, itself. So, well, I'm sorry. Was that 37 you were referring to this one or this one? The one on the left. So for this, okay, the one on the left, yeah. So that component is component number 3. That makes sense. Because it seems like on this diagram system, they put the component number to the upper left-hand side of the actual piece, right? So this one's a fuel pump. So the fuel pump is going to have 2 wires, of course. This black wire, which is the ground wire, because it's going to this little bus bar right here. And then this one was a supply wire that's going to deliver at 12 volts. That goes up to this component, K3, and that one is going to be the pump relay. The pump relay serves a couple of functions. Uh, do we see all of the functions that it serves? In fact, let me take another snip real quick. That way we can uh, interact with this and then chat about what it does. So you should be able to see this diagram, right? It is, if we highlight this one wire, that wire is the supply wire that goes up to the relay, and it goes to the pump. Is that the only wire that comes out of the relay? No. So you have 2 other wires in addition to that one wire that we highlighted that come out. There's 2 blue wires, right? So what does that other blue wire go to? We're talking about this wire right here. It goes to this device, right? Does anybody know or remember what that thing is? It's a lot of silence out there.
The oxygen sensor, right?
There it is. Yeah, oxygen sensor. So why would the oxygen sensor need 12 volts? Because that's what that component is going to do. I think I just lost my screen share, didn't it? It sure did.
Yeah, it just went away.
I'll give it back to you. Here we go.
Oh, now that you reshared it, I can see it
Oh, nice. Oh, shit. Hell yeah. That's all I needed to do the whole time. All right. Um, so what does that second blue wire do? Why does the oxygen sensor need 12 volts?
for the heater.
Yes, sir.
The heated oxygen sensor is 12 volts, right?
Absolutely. So that right there, that little electrical symbol is a heater. And you can see that this electrical symbol, um, that's going to be the sensor part. That's going to be the thing that makes the actual sine wave, right? That's a whole different circuit. So we need to think about those separately, right? So just to make sure that we're all on point with what we're looking at, that's the heater, that's the oxygen sensor, that's the fuel pump. And we have one wire that goes from this relay to the fuel pump, and we have another wire that goes from that relay to the O2 sensor heater, and then we have one last wire, this one we haven't talked about yet, and that's this red one, right? What does that one go to? And I can move this out of the way if it helps. Can't see it again. Lead on is correct. It is a PCM. You're still booting up your computer too, Jay? I am recording this session for you, Jay, so in case you need to see it later. I understand if you can't participate because your computer's not not doing the right thing. So that is the PCM. So why would this pump relay, right, the K3 relay, why would that thing be sending voltage to the PCM? We all know that voltage needs to come to the PCM in order for the PCM to work, of course. Is this pin 4 one of those wires that delivers power to the PCM for the PCM to work, or not? What is the opinion on that wire in the room? It is, yeah, yeah. That's a really good description of it. It's a signal wire, and the signal that it's trying to deliver is a signal of the relay itself being closed. So if the switch inside the relay between pin 2 and 3 of the relay is closed, then it's going to take 12 volts from fuse F11 and then deliver it down to pin 4 at the PCM. So this circuit right here is called a diagnostic detection circuit. And that's its only purpose in life, right? If this wire weren't here, would the fuel pump still work? Absolutely. You know, we could remove this wire completely, and just as long as the PCM can turn this relay on, well, that fuel pump is going to work, and also the oxygen sensor heater is going to come on. So the purpose of this wire is for the PCM to be able to understand that the fuel pump relay is working. So how many volts should we have on pin 2? Let's make sure that we're all good there, because this is the last part before we start getting our tools out. So it's always nice to know at every point in the circuit what should we have. Yeah, so definitely. So I want to have 12 volts there, And is it a 12 volts always or 12 volts sometimes? Yes, that's even better. You said it better than I did. In fact, I'm going to switch it uh, to B plus. Okay, so that's going to be our source voltage. Whatever the battery positive is, that's what I'm going to have there at pin 2. Is this a sometimes or a always? Sometimes. And why is it sometimes? Can you describe why is it a sometimes? Yeah, key on voltage. So there's a precondition that needs to exist, that the K2 relay has to be energized in order for these switches to be closed, in order for fuse 11 to get 12 volts, in order for pin 2 to get 12 volts, or battery voltage, right? So B plus. So that is the precondition there. So it's important to understand that, because now we know that our key cycles and also the PCM being plugged in or not plugged in is going to affect the voltage that we have at pin 2. If I have my PCM unplugged, I'm not going to have B positive at pin 2. If I have my key off, we're not going to have B plus at pin 2. Thumbs up if that makes sense. Lazak. I got 1 thumbs up. Yay. Ooh, 2. I got 2 thumbs up. 3. Okay. I'm going to go ahead and say that's probably good. So we're all good there. I'm going to keep on going. What should we have at pin 1 of the relay? Ooh, we should have a sideways. Is that explain? Sideways arrow. 0 volts. Okay. Um, well, let's think about that. Should we have 0 volts at that? It depends on what is on this line. Yeah. What is at B? So at B, this is going to go to the battery, and also A is going to go to the battery. It's not shown on this diagram. It continues on in another diagram. So every one of the big lines there at the top is going to have positive voltage. So since there's no separation between that black line right there and then this wire, at pin 1 we're going to have source voltage, so B plus. Now I'll ask you the question again: should it be B plus all the time or sometimes? So we're going to have B plus there, sometimes or all time. Hmm.
Only when the key's on, right?
Yeah, it depends on, yeah, it depends on where my B voltage is coming from. So it's either going to be on a key on basis, or it's going to be all the time, right? But yeah, I think the B wire is going to be key on voltage delivered. So I have to have my key on in order for the pin 1 to get voltage. What about pin number 4? What should I have there? Remember, we're just looking right here. This is just a zoomed in so I can write on it. So what should pin 4 have on it?
Pretty close to 0, right?
Close to 0. So let's do B minus or 0 volts. Is that a sometimes or all the time?
It's gonna happen whenever you have 12 volts at the other terminal.
Ooh.
So,
So
or no, it wouldn't be all the time actually. I don't know what I was thinking.
well, no, let's think about it. So if let me get another grab real quick because I need a little bit more context. So we do agree that pin 4, in order for the relay to be on, has to be 0 volts. We do agree that the 0 volt is going to come from ground from inside the PCM, hopefully. But one thing that we might not have an understanding on intuitively is that it's going to come from a switch because it's not explicit. A lot of the diagram systems, that whatever's inside the box, they don't show. So that's kind of tragic, right? It's basically you're left up to your own devices in order to understand what's going on in the inside of the box. But some diagram systems, in this one, right, it shows you what's inside the relay, so you know you have switches in there. So one thing you should ask yourself is, if K3 is the fuel pump relay, should my fuel pump relay be on whenever my ignition is in the on position? Or should it come on temporarily, then turn off, and then when the engine is cranking or running, turn back on? Which one of those is more true?
I'm going with the second.
The second one? Okay. Well, why is that the
I
case?
didn't really hear the first. I didn't hear the first one. I just heard the second one on
Oh,
the computer. But
okay.
whenever you turn the key on, usually the fuel pump only runs for a few seconds and cuts off the prime the system.
Exactly. So that function of this little switch inside the PCM, which is a transistor closing and then opening up again, is called priming, right? That's what happens when the key cycles forward. And then when the PCM detects that the engine is turning, it's going to go ahead and close that switch. And as long as it sees crankshaft signal, it's going to go ahead and keep the switch closed. Can anybody tell me why uh, this switch is just not closed whenever the key is on permanently, right? So you key on and the switch is on, and then that fuel pump relays on and the fuel pump's on. Why do we not want the fuel pump to run when the key is on but the engine is not running?
Well, it's just going to keep building pressure and the fuel has nowhere to go.
Well, but there's a fuel pressure regulator, right?
A whole bunch of fuel into your system, right?
Well, so the fuel is going to get into the engine when the injectors are on. So just because the fuel pump is running doesn't mean that we're going to have fuel going into the engine, but we will have fuel go to the rail, right?
Yeah. But you don't want the fuel pump just to keep spinning for no reason if you don't need it to.
Yeah, so one reason, like the pragmatic reason, is just you're just going to have a parasitic draw. Any electrical load consumes energy from the battery system, so you don't need the battery system to be consumed while the engine is off, but the key is on, because it's just going to drain the battery down. For big startup, need fuel volume. Yes, yeah, we do need to prime the system for that fuel volume to be available and pressure to be available when we first turn the engine on. But let's say for example, you're doing some engine work, you disassemble part of the intake system, and you need to roll up the windows because the car is outside or whatever. Well, in disassembling the intake, you might have disconnected the fuel lines, and in order to roll down the window, well, you need to turn the key on. Well, that if this system, when the key is on, turns on the fuel pump, then it's just going to start pumping buckets of fuel out everywhere, right? The alternative is a prime, which is going to put, a substantial amount of fuel, but it's going to be like, I don't know, a third of a cup, maybe less than that, worth of fuel out there, right? So it's less dangerous for the system to have just a prime and then a check to make sure that the engine is turning to qualify the condition for the fuel pump to be on. It's really a safety issue, right? Another thing is, let's say you get into an accident, uh, and the engine stalls out. So the engine's not running, but you have maybe a fuel line that's cut. Well, if the fuel line is cut, but you have your key in the on position, the engine's not running, uh, so you don't have crankshaft input. If that fuel pump relay is turning, then you're just, if that fuel pump relay is on and the fuel pump is turning, you're literally just pouring fuel out, right? So if the engine cannot run because the fuel supply line has gotten cut off, then the system is going to prevent the fuel pump from being energized by default. So it's like a fail safe mode. I remember one time, it was a Lexus like SC400 that had a part that was obsolete. It was a fuel pump control module that was messed up on this guy's car, and it was obsolete. There was some potential of ordering one from Lexus. It was gonna be like a month and a half out, and the part was like $1,200 just for the module, the computer that turns on the fuel pump. But he wanted me to bypass that module with an external relay. But I did not have a way to make that relay run only if the engine was running. And then he said, just do it anyway. I ended up having to refuse that bypass because what would have happened if he would have got into a wreck, right? If he gets into a wreck, the fuel line gets cut, the engine is off, and that fuel pump keeps on spinning and he's unconscious, he can't fucking turn the key off. Literally, the car would catch on fire because of the bypass that I did, right? So you put yourself in a predicament of potentially causing like life loss because you're bypassing a safety system. So again, the reason that this number 4 wire is ground only when the engine is running and only for priming is to save the vehicle from potential fire after collisions. This is not a system that you can bypass. So that makes sense to everybody? Thumbs up. Anybody that doesn't give me a thumbs up, I ain't let you work on my car. You dangerous. Okay, 1, 2. All right, and last but not least, pin 3 needs to be what? What does pin 3 need to be as far as voltage wise?
Just what voltage it needs to be right now when it's off or on.
So we're trying to use this diagram in order to understand the voltage that we expect to find during different conditions. So pin 2 is going to be battery positive or source voltage when the key is on. Pin 1 is going to be the same, battery positive when the key is on. Pin 4 is going to be ground during the prime and also when the engine is running. And pin 3 is going to be what?
Voltage.
Voltage.
It's on because it's a switch.
Voltage when what like key or engine conditions are going to be required to make that thing go to voltage?
Key on.
Key on for
voltage,
prime.
And then when it's running.
And then key on running. So if we leave the key on for long enough, this is going to go from voltage back to ground, right?
Yeah.
So that should be a normal thing that we see. So just as long as we understand what normal is, then I am a happy camper. So we can get into some diagnostics. So at this point, I can probably put my scan tool at least back for now. And then what tool do we need to get next out of the tools that we have?
You got a scanner.
Oh, you want me to pull the scanner? Yeah, I got the scanner. Well, sometimes the scanner actually gives us a little bit more information. Right here, we might be able to get a little bit more information. That's germane to the thing that we're doing. So there's the wiring diagram information. So it's a lot of the same stuff that we already talked about. So, so You say voltmeter? Is that what tool you want to use? See? Yes.
See,
See? Okay.
see, yes.
See? Yes. Okay. So I got my multimeter out. I can't hear you. Okay. Now, what do we do next? Where do we want to go to address the symptom that we have? Remember, the symptom is fuel pump continues to run with the key on and engine off. And we want to check the relay circuit of the fuel pump and repair as needed. We want to go to the fuse box, absolutely. So I'm going to zoom into this area. And what is the number of the relay that we're supposed to be making diagnostics on? Y'all remember that or no? So I have 3 relays here. I have K1, K2, and K3. Which one is the relay that I care about? Yeah, I need to be at K3. And I really want to break this down into the simplest parts, right? I don't really want to unplug anything yet. I'm going to get my digital multimeter. Which one of those pins do I want to check first? Okay, so let's do pin 1. What should I expect to find at pin 1?
Source voltage.
Source voltage. How do I use this digital multimeter to check for source voltage?
Positive lead in the pin connector and then ground the black wire, the ground wire to battery ground.
Okay, so black wire to battery ground. I got to set it on DC volts, which I love. Right, so DC volts is over here. And I have a bunch of settings for DC volts. Which DC volts am I going to use? I have 600, 200, 20, 2, and 200 milli. So 20 volts. Okay. I don't want to be a fool, right? So what am I going to do? Don't be a fool. It's been a long time, right?
Stay in school.
Stay in school. Oh man, you're fucking, yeah, I like it. So for me, it's don't be a fool, test your tool. So what I want to do before I start probing anything is I want to make sure my meter works. And I already see something going on.
Ohms.
Ooh, no. So I'm gonna use, so the ohm section of this is actually a separate tool inside the tool. Right? So since I'm using this particular meter for volts, I want to make sure that the volts functions. Right? So what do I see wrong right away? Yeah, the battery is low, right? And why would it be low? Didn't it just start when we got here? Yeah, I mean, it started, we drove it in. So why is it low right now? What do you think?
Well, the key is in the on position.
Key's in the on position, so that's causing a parasitic. The car is not running. Yeah, our RPM is 0.
It's in the on position, so accessory stuff is on, so it could be draining the battery.
Okay. Could also that fuel pump being on and running also cause an extra parasitic draw?
Yes.
Yeah. So what tool do I need to get next in order to correct this condition? Because yeah, we're already at fucking 9 volts, man. We're not doing good.
Turn off the key. Turn off the key.
Turn off the key. Stat. So what? Is there a tool that I need? Yeah. There we go. Gerardo said it. We need a jump starter. Put the jump starter on. Now I can use this in order to do some testing. Make sense? Hopefully so. All right. So pin 1 is going to be what color? Looks like it's, yeah, orange with a tracer. It's kind of a red tracer. Let's see.
On the right. One on the right.
Yeah, K3, right? There's one right here. Oh yeah, you see it.
Well,
Yeah. Got you. Let me get my probe lead. Zoom down onto this. And hopefully if it's all good, I'm going to find our source voltage there. And I do see source voltage. So that's a check, right? That is an appropriate test result. So what I'm going to do here is I'm going to put a check mark. So that one's good. Where do I go next? What pin do y'all want to check next?
I guess.
Yeah, might as well check 2. That's no problem because we expect to have source voltage on 2, and we already have our meter set up to check for source voltage, right? So we just move this on to 2, and if the key is in the on position, I should still have that. And then 2 is which one? This one right here? Is that? It's the top one. That one. Okay. So 13.94. So that is definitely also a check for this one. Where do we want to go next?
I want to go 3 or 4. I mean, that's the only options on it. They said 3.
Okay, let's do 3. So 3 is a yellow, or I'm sorry, orange wire. And what should,
The top and the bottom one.
yeah, the bottom one, what should we have there?
Well, if it's running, it should be source voltage.
But it's not running. Well, you say since the fuel pump is running, but the
Yes.
engine is not running right now.
Yes, it should be 0.
It should be 0, but it is 13.89. So all that does is it verifies that the fuel pump is getting powered up, right? It doesn't really do anything diagnostically because this is the output of the relay. So we can call it bad. So we can put an X on there, then we can call that bad, but that doesn't mean that the problem exists here. It means that the... Go ahead.
4. Well,
So the next place that we need to go is 4. Do we agree? Okay, so what should we have at pin 4?
0 volts.
Should we have 0 volts there?
Isn't that dropping all the voltage from 1 to 4?
So we should have ground at 4 if the PCM wants the fuel pump on. So
Once it off.
yeah, because the key is on and we already did our prime cycle, right? So we should really have 12 volts there. We should have our source voltage, right? So let's see what we have. And we do have our source voltage. So at every one of these pins, right? Every one of these pins we had 12 volts. Does that match up with what we should find in the real world? For pin 1, yes. For pin 2, yes. For pin 3, that one checked out, but it checked out bad. Pin 4, yeah, it's getting what we would expect it to find. If 4 had ground, then the problem would be on this wire or inside the ECM. Another way you can do this is let's zoom out. Let me get my digital multimeter lead. Let's say I want to see if the relay is getting turned on. I can check on these 2 terminals, right? Because this is pin 1. Yeah, this is pin 1 and pin 4. Is that right? Yeah, pin 1 and pin 4. And then what do I need to do with my key? I would need to cycle it, right? And you saw that it went to source voltage and then down, right? And if I start it up, should have source voltage. So that means that the control side of the circuit is working just fine. So far, so good.
And they're gonna be short at the fuel plant.
So let's think about that. So if I get back into my wiring diagram and I suspect like this wire right here, or that one, or that one, or that one to have a short to power, how can I check for that? So the question is, how do you check for a short to power on a wire? Can anybody guide me on that process? How do you check for a short to power on a wire? Just replace the wire and see if it works.
Well, you probably would disconnect the power from where it's supposed to come from, correct?
I like that. That's a good start. So I'm gonna take the relay. I'm gonna get my meter off of there. I'm gonna take the relay and disconnect it. Then what I do next? Oh shit! If the car starts, it's fun. If the car starts right now. All right. If the car is started, then yeah, we do have a short to power. That is another way to check for it. I didn't think about that one, so that's a good a good clue. What is the official way to check for a short to power? Using a tool.
It's just like a voltage drop all the way across each connection to see if there's a different ranging voltage, or if it stops and comes back, or what?
So voltage drop is that word is used to check for resistance, right? So if I want to do a voltage drop, I'm going to go from one end of the circuit with one lead and then the other end of the same circuit with my other lead, and I'm going to see if I have voltage potential across it. But doing a voltage drop, I have to have my circuit plugged in. Does that make sense? So in order to do to check for a short to power, what I'm going to do is I'm going to put my meter lead on ground, and then I'm going to use the positive lead on the meter to check the circuit that I suspect. Does that make sense? Okay. So which pin do I need to check in order to check for a short to power on the suspected wire?
On 3.
Exactly.
You check
No.
the bot.
Then on this one, you say it's the bottom one? This one right here?
Yes.
Yes. All right. So testing it, I have 0 volts. That means I don't have a short to power. Is that the end of the diagnostics? Can I replace the relay, or is there another test that I can do?
You can swap the relay and replace it.
I can swap the relay. Is there? So I'm gonna let you know this. This fucking relay is $150 because it's solid state. You gonna buy another one and put it in? Or is there another test that you can do on this relay to make 100% sure that indeed you need a relay? Okay, how do you test the relay?
The relay was working fine whenever we were testing on the voltage.
Ooh, what was that? The relay working fine, or was that the voltage going to the relay being fine?
I mean, we can test the relay, test its continuity.
I like that. I like that. So I'm going to put it on. You want to put on ohms or continuity?
Can you do the same thing with ohms? Test for continuity in ohms?
Yeah, but one is going to make a sound.
Gotcha.
So the continuity tester is that one that has like the sound waves coming out of it, and then the other one is going to be just resistance.
Or ohms.
Right. So again, don't be a fool. Test your tool. If I put one lead down and I touch the lead together, it's gonna make that BP sound. Otherwise, I can just use ohms, and it tells me, okay, 0 ohms of resistance between those two. So which two pins do I need to test for the circuit? So let's say I wanted to test the control side of the relay. Yeah, you said between 1 and 4? Okay, so between 1 and 4, approximately how much ohms should I get? What's your gut feeling say?
For a relay?
Yeah, for a relay.
Like 120 ohms or something like
Okay.
that. 120 ohms.
Pretty fucking good guess. I like that. So let's see what we got. Okay, so 45 ohms. What we can do is we can look under specifications and see if that's right, or if we have another relay that's the same, we can test it as well and then do a compare contrast. But for this, I mean, if you want to, yeah, we can. What other relay is the same style on our circuit? K1, right? So we can pull K1 relay out and then do the same test on it. Okay, and we got 45 ohms, so that's same. So that should be good. So what's the second part of the relay?
I can't see. The other side, the other two, which
Okay.
should be open. If it's out, it should be closed. It should show OL.
It should be OL, yeah. So between 2 and 3, it should be OL. Just to prove it, we're gonna look at this relay K1. We're not getting a code for it, or hopefully don't have any problems with it. And yep, open circuit, right? So let's move this one here, and it has continuity between two relays. Damn. Okay.
Uh-oh.
Oh
Staying
shit.
closed at all times.
Yep. So that's a relay where the switch side of the relay is bridged internally. So at this point, now I can spend $150 on that relay. So I'm going to take my wires off, take my relay. I need to open up my little panel here. Drag that here. Then replace the part. Put the new one in. Plug in the K1 relay. For me, before I even take this and put it into the vehicle, I'm going to go ahead and do that last test that I did to condemn this one to make sure I actually have a good replacement relay, because sometimes my customers get their parts from a store that's orange and white. And you don't exactly get the, yeah, well, it could have been autos, it could have been somewhere else. So yeah, definitely an open circuit here, so that's good. So I'm going to plug that relay back in, key off, key on, start it. That's good. And then I'm going to go back into the engine management system, retrieve fault codes, and I have a shitload of fault codes. So I am going to turn this off, key on engine off, delete fault codes. Then I'm going to key on an engine off again, start it, and let's see if I get any fault codes. I just have a crankshaft position sensor circuit range performance error. It's a memory code, not an active code. We shouldn't be worrying about that one. Now, the last part of this is I'm going to have to put up all my tools. So let's see, put up the diagnostic tester, the jump starter, the multimeter, and then on the work order, I would just put in my notes. Found.
Might need to put a battery charger on there and charge that battery.
I know, right? Replace battery, upsell. Found faulty relay.
Toyota sent me out to a lady's house today to replace the battery in Avalon in Georgetown.
Oh shit, really?
Yeah, that was pretty cool actually. I was like, yeah, I'll leave here for a little bit.
Oh man, yeah. Especially on days like this, man, that's the best thing right there. So you click that fail was resolved, click that you verified the repairs and the diagnostics and work was performed. We'll put up, we'll even put up the instrument cluster and return the vehicle to the customer. You got a check mark, close that, exit. Got it? Any questions on over that particular diagnostic process?